Today we are going to talk about logic flow diagrams, and basically if you know one way of solving one of these flow diagrams, you can solve pretty much any other flow diagram. So of course, with all your flow diagrams, you're going to start off with your variables, okay? So in this case, you've got sum equals 0, count equals 0. So we put that down. We put sum, count, and it's always easy to do it in a table format because it actually makes your life a lot easier with keeping track of how the values change and what they are. You've got sum, count, and then they put x and y in, which are other variables as well. So the question goes, if your x is 5 and your y variable is 3, what would be the output of the flowchart? So we put down what the variables are in terms of what they declared. So sum is 0, count is 0, x is 5, and y is 3. So we go through the flowchart. Count is equal to count plus 1. So that's 0 plus 1, which would give us 1. Sum is equal to sum plus x, which is 0 plus 5, which is going to give us 5. X is equal to x plus 1, so that's 5 plus 1, which is 6. Okay, is count equal y? So y is 3. Count is not equal to y because count is 1. So no, we're going to go this way. Count is equal to count plus 1. So it's 1 plus 1, which is now 2. Sum is equal to sum plus x, which is 5 plus 6, which is 11. X is equal to x plus 1. So 6 is now 7. Okay? Is count equal y? No, it is still 2. So now we go back. Count is equal to count plus 1. So it is now 3. Sum is equal to sum plus x, which is 11 plus 7, which is 18. X is equal to x plus 1, which is 8. Is count equal y? Yes, your output is sum, which is 18. So it's always great to do it in a table form because if they ask you how many times does count equal count plus 1 execute, you basically leave out the first row and you count the others. So it executes, iterates, or loops 1, 2, 3 times. So if they ask you how many times it executes, loops, or repeats, all these 3 words basically mean the same thing. Okay, basically it goes around in this loop structure 1, 2, 3 times. Also, it's nice to keep this table because they do ask you certain questions, like, for example, when count is 2, what would the value of x be? And if you, of course, have this table, you would be able to say, well, x would be 7. So this is how you do a flow diagram, and you're basically going to apply this logic to every other flow diagram that you do. So again, I hope this helped you in some way for your test. All the best.